Okay, so today we are going to talk about electrolytic cells. And so I thought the best way to do this was to compare the voltaic cell that we've talked about, okay, also known as a galvanic cell, to our new cell for the day, which is electrolytic. And then once we've compared the two, we will go and look at a diagram of both of them and compare and contrast those also. All right, so here's the first thing let's talk about what we know about a galvanic and what's different in electrolytic. So in a galvanic cell, we should know that these reactions are spontaneous. So in other words, electrons want to flow from the anode to the cathode. In electrolytic cells, these are non-spontaneous. So electrons do not automatically want to flow from the anode to the cathode. Okay, so if in an electrolytic cell, we don't automatically have electrons that flow through from the anode to the cathode, we have to force them. So the way we are able to do that is that we put energy in. So that makes this an endothermic process. Whereas in a voltaic cell, this is an exothermic process. Okay, so what's happening in these cells for them to be endothermic and exothermic? So in electrolytic cells, we are putting in electrical energy. And we're using that to produce a chemical change. So probably a really great example of this from first year chem is probably in the chapter where we did the types of chemical reactions, and we probably showed you the decomposition of water into hydrogen and oxygen. And we used a battery to do that. Okay. In a voltaic cell, it's the opposite process. So we're taking that chemical energy and we're using it to make electrical energy. All right, and probably the one last thing we should probably talk about in terms of voltaic and galvanic cells is that remember in the voltaic cell, you have a positive cell potential. And in electrolytic cells, we're going to have a negative cell potential. Okay, so electrolytic cells. When we recharge batteries, that would be an example of an electrolytic cell. You're reading from the week where you're talking about corrosion and you're talking about batteries. When it talks in and plating out, so plating to prevent corrosion, an example of electrolytic cells. The production of aluminum would be an example of an electrolytic cell. All right, so let's look at our diagram here then. So the image on the left is your galvanic cell, and the image on your right is your electrolytic cell. And this is the same image in your book on page 729. And you're more than welcome to pause the video to draw these into your notes. All right, so you can see lots of things they have in common. Both have an anode and a cathode. And we could have even drawn the electrolytic cell so the anode would be on the left and the cathode is on the right. You can see that they have ions in solution, just like a galvanic cell. You can see that they have a metal electrode, just like in the galvanic cell. You can see that electrons are flowing from the anode to the cathode, just like a galvanic cell. You can see that there is a semi-permeable membrane or a salt bridge. And you can see that the anions are flowing into the anode and the cations are flowing into the cathode. Okay, but the big difference here is the species that you're putting at the anode and the cathode. So before, the one that had the higher reduction potential, we put at the cathode and it would undergo reduction. But in this case, we are going to put that species at the anode. And so when we add them together, we're going to get a negative cell potential here. And we're really using this process to produce a chemical change. Okay, so those are your notes about how to label and diagram an electrolytic cell.